Okay, now that you've built your nightlight, let's go ahead and get it coded. In order to do that, we're going to head to create.arduino.cc and log into the web editor. If you don't have an account at the web editor, then you can watch the video at the MakeCreate community that'll tell you how to get started there. And get yourself an account and get logged in order to write sketches for your Arduino. This is a pretty long coding tutorial, but it teaches some really useful troubleshooting techniques you'll use a lot later on. So definitely recommend that you hang on till the end. Now that we're logged in, you can see that there's already a sketch that I wrote previously in the screen. We're going to go ahead and write a new sketch, so click the new sketch button. If you saw that flash across the top of the screen, that was just indicating that I didn't have a board attached to my computer. Obviously, we will need to get one. So there's the new sketch. You can see that it opens up to the beginning screen for all of our sketches, and we can go about writing some code. Now that we've opened a new sketch, we're going to go ahead and give it a name up here in this comment section. Remember that that slash and asterisk define a multi-line comment in Arduino. And then we're going to define a variable for each of the pins that we've connected to on our microcontroller. We do that so that at any point in time, if we reconnect our board, maybe one of our pins go bad, or for some other reason we need to shift from, say, pin 7 to pin 6, instead of having to change the value throughout all of the code, we can just change it up here in the beginning. So we have 3 LED pins hooked up to 7, 8, and 9 on the Arduino. So we're going to name them LED pin 1, LED pin 2, and LED pin 3, and assign them to the values 7, 8, and 9 in our code. These are digital pins. They're going to recognize on and off values. We also have our sensor hooked up to an analog pin, A0. So we'll note that here. And the difference is that instead of just taking an on or off reading from an analog pin, we can get readings that are on a continuum. So we'll see once we get this running that our sensor values actually can vary from 0 up to about 1,000 in this particular case. All right, so we've got our variables defined now. The other thing we need to do for the pins we've connected to is define them as either inputs or outputs. We always do that within the setup section of our sketch. And we have 3 outputs in this particular case. We'll be using the LEDs as outputs in this particular case, and then our sensor is an input. So in order to define those, we're going to use the pin mode function, and that requires 2 values. First the pin, and then either input or output depending on that particular case. So we'll use pin mode LED pin 1, LED pin 2, and LED pin 3 as outputs. And then we will create our last input using pin mode for the sensor pin. Okay, the next thing we're going to do is going to be a little less obvious than maybe what we've done up until this point. There's a technique when you're writing Arduino sketches that's really useful for troubleshooting, and it involves something called the serial monitor. This is a place where when we are collecting values using the sensors attached to our Arduino, we can actually display them, and that will help us to troubleshoot. So in this particular case, as we're collecting our light values, we might want to be able to see what they are in order to adjust our code. So you can see the serial monitor over there on the left-hand side, and we are going to open that monitor or start that monitor using a little bit of code. And so the function we need to use here is serial.begin. And then we have to give it a rate. This is the rate at which it communicates with the serial monitor and the Arduino communicate with each other. And 9600 is a pretty standard value, so that's the value that we will use there. Okay, our sketch is now completely set up, so we could start to think about what needs to happen within our loop. Before we actually write code, we're going to start by just writing a little algorithm that defines what behavior we want to see. So we'll do that using single line comments. Those each start with 2 backslashes. And we know that the very first thing we want to have happen is we want to read how much light is in the room. So we have to figure out how much light we're seeing and then respond by turning on the right number of LEDs. So after we've read that amount and we know what it is, if it turns out it's pretty dark in the room, we're going to want to turn on all 3 LEDs. So our next step in our algorithm is going to be to say that if the room is really dark, turn on 3 LEDs. Then we'll have another case where maybe the room isn't really dark, but it's a medium amount of darkness. And so in that case, we're going to want to turn on only 2 LEDs. Now, obviously, really dark and medium amount of dark are not values that the compiler understands. So at some point, we are going to have to go back in and define those very specifically for the compiler to recognize, and you'll see how we'll do that in a minute. And then we might say if the room is just slightly dark, go ahead and turn on 1 of the LEDs. So that'll be the next step in our algorithm. And again, slightly dark will require a little bit more definition. And lastly, we say if the room is light or anything other than the 3 cases we've just defined, then don't turn on any of the LEDs, so we'll leave them off. Okay, now that we know exactly what we want to do, we can start to code it. So the first thing we have to do is read the amount of light in the room. Now, that requires getting a reading from our sensor pin. That reading is a value that we're going to want to use repeatedly through the next 4 steps in our algorithm. We're going to want to compare it to the light values and see whether or not we have to turn the lights on. So what we're actually going to do is define a new variable here. And we're going to define that variable as an integer. And we're going to call it sensor value. And we're going to let that equal the light reading that we get from our sensor. And the way we collect that information is to use a function called analog read. It's an analog read because it is an analog pin. And so here we're going to tell it to read the sensor pin. Since we've set sensor value up as a variable, we can now use it in the other 4 lines of our algorithm without having to get a new reading on our sensor pin. Since we just took a reading from our sensor pin, it might be really helpful at some point in the future as we're troubleshooting to be able to actually see what that value was that we read. So here's where we're going to use our serial monitor again, and we're going to display the value that just got read in on our sensor pin. And the way we do that is to use serial.println. We print a line so that we get a return value after it and can actually tell the numbers one from another. And just end that with a semicolon. So we're going to print out the sensor value, and that with a semicolon. Remember that all of your lines of code need to end with that semicolon in order for the compiler to be able to read them. And then we will move on to the next step in our algorithm. Now that we're moving on to the next line of our algorithm, it's time to think about what it means to be really dark. So we know that our sensor values are going to be integers greater than 0, and the higher they are, the more light there is in the room. So we're going to start off in a fairly arbitrary place. It's not completely arbitrary because I've worked with these sensors before and I have some idea where to start. But we're going to define a new variable that sets our room darkness level that we're willing to work with. And that's a variable that we can change at any point in time. If we want to have the LEDs come on when the room is less dark, we can always alter this value. But we're going to start it off at 700, and then we can change that going forward. So we make this variable called dim, set it equal to 700, and then come back into our code down here in the loop, and we're going to use an if-then statement. And it's going to say, if the room is more dark than 700, so if, open parentheses, in your if statement to define the Boolean, so if, open parentheses, sensor value is less than dim, so that means we're getting a reading less than 700, then we use a bracket to define what happens, and we're going to turn all 3 LEDs on, and we do that using digital write. So these are digital pins. They have 2 values, on or off, essentially, and writing to them means we're making something happen on them. So we're going to digital write LED pin 1 to high, LED pin 2 to high, and LED pin 3 to high in this particular line of code. Or section of our code, I should say. Now that we've defined our original darkness level, for the next section of our algorithm, we need to think about what it might mean to describe a medium amount of darkness. So a clever way to do that, so that we can alter it pretty easily later on if we need to, is to create another variable. We'll call this our variance, and this is going to be the amount we add on to our dimness in order to determine what we're going to call a medium amount of dark and a slightly less dark room. So in this particular case, we'll define it to be a value of 100. That again is like our 700. It was a little bit arbitrary, but we have total control over it by defining it here. We can make changes to it really easily later on if we want to. So we'll define that, and then we're going to define a new variable called less dim, and that's going to be dim plus our variance. So in this particular case, it'll have a value of 800, but again, we can change that pretty easily by changing those other values earlier. And that's what we're going to use in our medium amount of darkness section of our algorithm. So we can head back down there, and we're going to need another if-then statement, but since we already started with an if, in this particular case we're going to use else if. So we have our first if that doesn't what happen, if that's not what happens, then we say otherwise, else if, do this next thing. So if our sensor value is less dim, so we have a medium amount of light in the room, this time we're going to digital write 2 of our pins to high and the 3rd one to low, because we only want 2 LEDs to come on. I'm going to do that slightly more efficiently by cutting and pasting, and then just changing that 3rd value to low instead of high. Okay, now we need to think about what slightly dark means. So we're going to do something similar to what we did before. We're going to go up here and create a 3rd light level value. We're going to call that least dim. And we are going to set that equal to our previous value, less dim. And again, we want to add on that variance. I'm going to move some things around here, just tidy up my code a little bit. I'm going to put the variance up at the top so that my 3 light levels are right next to each other. And then, if you look at that, you'll see instead of doing less dim plus variance, I did less dim plus 100. I want to fix that because I only want to have to change my code in 2 places later on if I decide to alter those values, and I can just change them at the variance and dim line, and then the changes will filter through the rest of the values. So now that I've got that defined, I'm going to head back down to my algorithm, and I am going to go ahead and write the code for the last section. I'm going to do that again with a cut and paste. So it's still an else if statement, and this time I'm going to have change the Boolean value to be least dim, and I'm going to set it so that my first LED is high, but the other 2 are set to low. Okay, now the last section of our algorithm is what we do in all of the other cases, which should be pretty apparent that really the only other case is the room is pretty light now. We don't want our nightlight on. So instead of using an else if, we just use an else, and that denotes this is what you do in all the other cases. We don't really need a Boolean there because the again, we're encapsulating every other case here. So we'll just open our bracket. Again, being a little bit lazy here, I'm going to cut and paste my code, but this time instead of having a high value, I'm going to switch them all to low. Tidy that up a little bit, and then we've got our code complete for our nightlight. Okay, a quick review of everything that's going on in this code before we connect our board and make sure it's working. We've got our variables defined at the top, our LED pins connected to 7, 8, and 9 on the board, and our sensor connected to A0. Remember, we define those at the beginning of our code so that if at any point we want to reconnect to a different place on the microcontroller, we can do that. Then we've got this variance, which is going to define the various light levels in our room, as well as dim, which is our initial value. And we add that on a couple of times. We're using our LEDs as outputs and our sensor pin as input. And we have turned on our serial monitor, and we've got a place down in our code where we're going to actually send values to that we can review. We've got the initial reading from our sensor value, and then the 3 bits of code that determine what happens based on the value that we receive from that sensor. Now that the code is written, we're going to want to verify it and compile it and get it to our board and make sure everything's functioning properly. So you can go ahead and get your board out and get it connected. I'm going to do the same thing here on my end. Once you've done that, remember to go up to the top here and select the board and port that you're connected to. I'm going to do the same right here. That makes sure that my communication is effective. And the first thing that I want to do is upload. Nope, you know what? I'm actually going to verify my code first, just make sure there's no mistakes in it. So I'm going to hit this check mark for verify. And wait a second, and look at that at the bottom. I've got an error. It says LED pin 1 was not declared in this range, and it's highlighted where that error is occurring. So let's think about what might be happening there. Okay, if you look at how I've spelled LED pin 1 in this particular case, it has a lowercase l, whereas in my variable declaration I used an uppercase L. And it looks like I did that for all of my LED pins, and that's a problem. The compiler is very, very specific about what it needs, so I need those to match up. So I'm going to change them in my variable declarations, and because it looks like I was consistent below, and re-verify that code, and this time it's working. So now I can upload it to my board. This might take a little bit longer, but we get that going, and I can start to see what's happening on my board. And what I am seeing is that I have an LED that is stuck on, even though it is light in the room. So what I'm going to want to do is use my troubleshooting serial monitor to see what kind of values I'm getting. And if you take a look at them, you can see now it's they're scrolling pretty quickly. It's a little bit hard to read. You can uncheck the box at the bottom of the screen, and that will allow you to slow that down, and we can see we're getting values around 700, or I'm sorry, 850. And so given the original dim value of 700 and the two variance values, the variance value of 100, it makes sense that since these are all below 900, that I have one LED that's always on. So what I'm going to want to do is raise my original dim value a little bit. I can do that right here. Again, this way we don't have to change it throughout the entire program since we defined it as a variable at the beginning. We can make that a little bit higher. And we can, again, verify the code and re-upload it to the board and see what happens. And this time I'm getting the correct behavior. So you can't see it from where you're sitting, but as I'm covering and uncovering my LEDs, they are behaving more appropriately. You can probably, if you look in that serial monitor, you'll see as I'm changing the values that the input values are actually changing over there. But that gives me a sense of where I want to set my initial value and how much I want to change it by. So you can do the same on yours to get it reading properly for your nightlight. And that should do it. So that is how you code the Light It Up project, so that you can have 1, 2, or 3 LEDs on in response to the amount of light in your room. Congratulations, you're done.